Okay, good day, good people. Let us continue with our strain energy. We looked at the gradually applied. Now we are looking at the suddenly applied. Now, a sudden load is a load that is applied instantaneously without impact and may stay for longer time period after application of load. Now we can associate with the suddenly applied load. Suddenly applied load, it's like you lifting up a box on the floor. Now you'd realize that how you would pick up that box, it will be suddenly. You can't pick it up gradually, or else you will feel the effect of the mass or the effect of the load that you are picking up. Now, hence you will pick it up instantaneously, like meaning quickly. So you will pick up that box on the floor. Yeah, let's say the box, it weighs something like 5 kg or 10 kg. You will pick it up suddenly. So because if you will pick it up slowly, you will feel the weight of that box. It is an unplanned load to which the structure is subjected. Okay. On this point, they are giving the picture. Let's say you were lifting something with a rope. Okay. Let's say you are having a rope. Then the rope, it has some block there at the bottom. Then there on top, maybe you have a wheel or a gear or something that helps you to do what, to pick up the load. Now all of a sudden this block gets to drop, boom. Then when it drops, it will obviously fall on this block here. It's unplanned. Now the speed at which it will drop and bang this block here, you would realize that it is unplanned load to which the structure is subjected. Then it will cause this block here to undergo stress. Then it will cause this block here to experience what? Extension or change in length, because it's unplanned load. All right. Now therefore, if that's the case, that which we are saying instantaneous load and unplanned load, that gives you the picture that F equals to 2 multiplied by W. This means that the stress and the extension will double as well, because this load, it is what? It is instantaneous. Now this gives you the picture that whenever you apply instantaneous load, you need to apply twice the effort. Like when you pick up the load on the floor, that box on the floor, you need to apply twice the effort for you to be able to pick up that box. This is what we are saying here under your suddenly applied. And if that's the case, that gives you the picture that the stress as well will be doubled, because it's unplanned. It's something that drops quickly. So, and the extension as well, it will do what? It will the extension as well, it will do what? It will double. That's what they are saying. Now, when we were calculating strain energy, we said the formula, it is 1 over 2 Fxt. Now we will be applying this formula as well under your suddenly applied, but the difference is that the F there, we need to multiply it by 2. We are having F equals to 2W. The F then needs to be multiplied by 2. That's where the difference is. But the formula, it is still the same. We will still use that formula, U equals to F squared L over 2AE. Now the difference is that when coming to F, we will then have to multiply it by what? By 2. That's where the difference is. Now let's do the application of the suddenly applied load. Now we are looking at this equation here. A steel rod consists of 2 sections. It's vertically attached with a length of 100 mil and a diameter of 50 mil, and a section with a diameter of 80 mil, a weight of 100 kilonewton. It's suddenly applied, causing strain energy of 10 joules, while E equals to the E there, it's supposed to be 207, right? The E there, it's supposed to be 207. Let's change it. It's supposed to be 207. You can tell that I was tired when typing the whole thing. 207, right? The E there, it is 207. All right, but anyway, it's fine, right? Now let's apply. Let's calculate whatever that they want us to calculate. Now let's take out the data. We are having two sections. We are having section 1 and section 2. This is what I think we have. We have L1 and we have L2. Then we are having the force applied, right? Then obviously we will have strain 1 and strain 2, strain energy. Then we will as well experience change in length 1 and change in length 2. All right, then we are having the diameter there. We are having the diameter. We are having the diameter there. Right, that's what we have there. Then the Young modulus, it is given as what? As 207, 10 times to the power 9 Pascal. That's what we have. And what else do we have? We have UT total, it is 10 joules. And what else it is given? Right, then we are given the dimensions of your diameters and all that. Now, the first question that they want us to calculate, they want us to calculate the length of 80 mil diameter. All right, they want us to calculate the length of 80 diameter. Right, now let's go ahead and do that. Now, in calculating the length, we first have to calculate the areas. Area 1 would be pi multiplied by 50. They said 50 divided by 4. Remember, they said, this is what they said. They said section is vertically attached with a length of 100 millimeters and a diameter of 50 meters. That's the first one that I applied in calculating the area. Then I get my area as 1,963, 10 times to the power negative 3 m squared. Then the second one, area 2, it is that one of 80 millimeters and a section with the diameter of 80. Now this one, that's the one that we are calculating its length, because there's no length for this one. But for this one, there is a length. Here's the length there. Yeah? Right, here's the length there. Right. Okay. Then we are having pi multiplied by 0.08 squared divided by 4. Then we get our answer as 5,027, 10 times to the power negative 3 m squared. Right, that's what we have there. Then we are having E. E is given as 207 gigapascal. Please don't forget that. UT is given as 10 joules. No? Right. Then they want us to calculate the L. In calculating the L, it will be UT equals to U1 plus U2, because we are given everything that has to do with with strain energy. If we were given the total change in length, we are going to use the formula of total change in length. Then we are having 10 equals to the formula, it is F squared L1 over 2 EA plus F2 L2. We are looking for L2, 2 EA2. This is 1. Now please don't forget that F equals to 2W. Then we are given F. It is given as 10 kilonewtons. Now let's go and look for that in the equation. Let's see. There it is. We are given the F there. It is what? 10 kilonewton. Can you see that? Now it means our F would be, our F here would be 2 times 10. Then it gives us 20 kilonewtons. This is our F. Then when coming to here and substituting, we will make F the subject. It is common. The F, it is common there. It will be F over 2E. E, it is common as well. Then we are having L1 over A1 plus L2 over A2. Now E, 2E, 2E, F, they are what? They are common. Yeah? Then we are having 20 times 10 to the power 3 all square root divide by 2 times 207 10 times to the power 9 square root. We are having our length, it is 100. The length for this one, it is 100. Then it will be 0, 1 divide by area 1. We did calculate it. It is 1,963 10 times to the power negative 3 plus L2. We are looking for L2. Then the area for L2, it is 5,027 10 times to the power negative 3. This is what we have there. Right. Then we will get our answer as 10 equals to 9,66 2 times 10 to the power negative 4 open bracket. Then we have 50,916. All right, plus, because 50, it will be 0,15 divided by 1,963 10 times to the power negative 3. Then it will give us 50,916. Then this one, it will be 1 over 5,027 10 times to the power negative 3. Then it will give our answer as 198,926 L2. Right. Then we will then divide the whole thing with 9,662, and this side as well we will divide by that. Then it will be 10 divided by 9,662 10 times to the power negative 4 equals to 50,916 plus 198,926 L2. Right, then we get our answer this side as 10. We get our answer as 10,349,824 minus, let's summary transpose this to the other side. It will be 50,916, right, equals to 198,926 L2. Therefore L2 would be in subtracting 50,918 from this one, we get our answer as 10,298,908 divide by 198,926. Then we get our answer as 51,773 meters. Right, this is how you tackle the first question there. Yeah? Now let's look at the second question. The second question, they want us to calculate the total change in length. Now in calculating the total change in length, I will write it here. It is total change in length. It will be UT equals to 1 over 2 FXT. Now don't forget that F equals to 2W. Whatever we do with F, we need to multiply it by what? By 2. Right, whatever we do with that, we need to multiply by 2. Then here it will be 1 over 2 multiplied by 2 FXT. 2 and 2 will cancel out. Then you will have FXT equals to UT. Our UT, our strain energy, it is 10. Don't forget. Then therefore our XT would be 10 divided by our F. It is 10 times to the power 3. Then our answer would be 1 mil. Right. This is how you tackle question 2. That's how you tackle question 2 in calculating the total change in length. Now let's look at calculating the total strain in the bar. Now, the total strain in the bar, they want us to calculate strain T equals to strain 1 plus strain 2. All right. Then we know that in calculating the strain, it will be stress over Young modulus plus stress 2, stress 1 over Young modulus. How so? We are having Young modulus equals to stress over strain. Then we make strain the subject of the formula. Then we will land ourselves with that. Then we will take out the common factor. It will be 1 over, then you will be left with stress 1 plus stress 2. Then we know that in calculating the stress would be force over area plus force over area to 1. Then we take out the common factor. The common factor would be F. Then we are having F over E. Then we are left with 1 over area 1 plus 1 over area 2. Right. Please don't forget that when coming to force, we are having force equals to 2W, because we are dealing with what? With suddenly applied or instantaneous load. That means here we will have what? Multiplied by 2. Right, then we are having 2 multiplied by 10 times to the power 3 equals to 207 10 times to the power 9. Then it will be 1 over 1,9. Remember, we did calculate the areas. It is 1,963 10 times to the power negative 3 plus 1 over 5,029 10 times to the power negative 3. This is what we have here. All right, then we will land ourselves with there it will give us 9,662 10 times to the power negative 8. When we divide 20 kilonewtons, because 2 multiplied by 10 kilonewtons, it divide by 207 10 times to the power 9, then it will give us 9,662 10 times to the power negative 8, open bracket. Then in the bracket, this one 1 over 196, it will give us 50 comma no, it will give us 500, not 50. It will give us 500. It will give us 509 comma 295 plus this one 1 divided by 5,092 10 times to the power negative 3. It will give us 198 comma 926. It will give us 926. Right, then we get our answer as, when we multiply and add the whole thing and removing the bracket, then we get our total strain as, remember, total strain it is the deformation, right, where the energy is stored, 10 times to the power negative 5. Right, this is how you apply and solve the total strain energy. Let's look at the last question there. The last question, they want us to calculate the maximum stress. We know that in calculating the maximum stress, we always calculate the maximum stress from the smallest area. Now it will be force over what? Over area. It will be force over area. Please don't forget that when coming to force, it will be 2W. Now the smallest area in this 2, it will be this one. This, it is quite bigger, because this one, its diameter, it is 50, and this one, its diameter, it is 80. Clearly this one is the smallest area. Now it will be maximum stress equals to force, remember, 2 times, then we are having 2 times 10 to the power 3, 2 times 10 kilonewton, divide by the area 1,963, 10 times to the power negative 3. Then we get our maximum stress is 10,183 megapascal. This is how you apply suddenly applied load, good people. It is easy, straight to the point. Then we will drop the last one, the shock. Then we are done with spraying energy. Thank you, good people.